Hello guys, in this video I'm going to be showing you how to draw Lewis dot structures by following certain steps. So this will be just an example, a video for examples. So our first example will be NH3, which is ammonia. So what you need to do here actually, first thing, you are drawing a molecule that has no charge, so you follow these steps. For nitrogen, from the periodic table I can know that it has 5 valence electrons. How many nitrogen atoms do I have here? I have 1, so I multiply this by 1. Next is hydrogen. Now from the periodic table also, hydrogen is in group 1, so it has 1 valence electron. Here in this molecule I have 3 hydrogens. Multiply by 3. 5 multiplied by 1 is 5. 1 multiplied by 3 is 3. So the total is 8 valence electrons. I'm looking to distribute 8 valence electrons throughout this molecule. So what I'm going to do here, first I'm going to position the central atom, which in this case would be nitrogen. I have 8 valence electrons, so if I divide this number by 2, because every 2 pair up, I will end up with 4 pairs. I will have to distribute, in this case, 4 pairs of electrons. What does 4 pairs mean? This is 1 pair, for example. 2 electrons next to each other. Or 2 electrons in a bond. This is 1 pair also. I'm not talking about lone pairs, I'm talking about just pairs. So let's check. I have 3 hydrogens. I'll distribute 3 hydrogens around the central atom, which is nitrogen. So these are 3 hydrogens. I'll have to start bonding. First bond, second bond, third bond. Now, as you know, hydrogen has a duet, not an octet. So the maximum electrons that it wants is 2. 1, 2, 1, 2, 1, 2 for each hydrogen. How many pairs did I use here? This is the first pair, the first bond. Second pair, which is the second bond. Third pair, which is the third bond. I need 4 pairs. So what should I do? I should add 1 pair to the central atom. So first you distribute, then what's left, like 1 pair or 2 pairs or whatever, you add it to the central atom. Now the thing here is that every atom needs to satisfy the octet, so it should have 8 valence electrons, except hydrogen, of course. It's an exception. It should have 2. So if you count here, for nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. It has full valence electrons, which is 8. Taking another example, now let's take CO2. Well, we're using this because it has multiple bonds. It may have a double or a triple bond. Let's check. So first step number 1, carbon. Each carbon has 4 valence electrons, because carbon is in group 14. And I have 1 carbon atom here, so multiply by 1, I will get 4. Oxygen. From the periodic table, oxygen is in group 16, so it has 6 valence electrons. I'll multiply by 2. Why? Because I have 2 oxygen atoms in CO2. I'll get 12. Add these, 12 plus 4, it will give you 16. So the total electrons that I need to distribute are 16. If I divide this number by 2, I'll get 8 pairs. 8 pairs of electrons that I need to distribute. Now, carbon is the central atom. How am I knowing the central atom? Well, when you have carbon, because carbon can make 4 bonds, it's always central. Usually the atom with the least number of atoms is the central atom. So I'll put carbon in the middle, oxygen, oxygen. Let's distribute the pairs of electrons. I'll start by distributing the pairs on the terminal atom. I have 8 pairs. 1, 2, 3, 4, 5, 6. I need 7 and 8, so I'll put here and here. Now, is this structure correct? Technically, we follow the rules, but we have ignored one really important thing, is that this atom, the central atom, does not have an octet now. It has 1, 2, 3, 4. Only 4 electrons. It needs 8. So I should redistribute in such a way that the carbon atom in the center has 8 valence electrons. How can we do this? So this is 1, this is 2, 3, 4. I'll put a bond here. Now what does this carbon need to have 8 valence electrons? It needs another bond. So this is the carbon atom having 8 valence electrons, and the oxygen also has 8. You will ask me, why didn't I put like here? Why didn't I put the electrons here? It would still have 8, but now oxygen would not have 8. If you count oxygen, 1, 2, 3, 4, 5, 6, it doesn't have 8. So these pairs should be shared between carbon and oxygen to satisfy the octet. Now let's count. For this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Octet is satisfied. For this carbon, 1, 2, 3, 4, 5, 6, 7, 8. Octet is satisfied. For this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Octet is satisfied. So this is the actual structure of carbon dioxide, and you have the pairs here, the lone pairs that don't participate in bonding. This is the actual structure of CO2. Now let's check an example of a polyatomic anion, which is PO4 3-. Phosphorus, it's in group 15, so 5 valence electrons multiplied by 1. I have 1 atom of phosphorus. This is 5. Oxygen. Oxygen has 6 valence electrons. It's in group 16. Multiplied by how many oxygen atoms do I have in this ion? I have 4. So 6 multiplied by 4, it's 24. Now I add 24 plus 5, it will give me 29 total electrons. But in this case, because this has charge, pay attention to this, because it has a charge of 3-. Now what does 3- mean? It means that this polyatomic anion has gained how many electrons? It has gained 3. So I should add these gained 3 electrons to my total. I will add 3 electrons here. So my total would be 32 electrons to be distributed. I divide this by 2 to get the number of pairs. I have 16 pairs of electrons. Let's draw it. Of course, you will notice that phosphorus is lower in numbers than oxygen, so you will put phosphorus in the middle, P. I have 4 oxygens. I'll distribute them on these sides. Now I will start filling the pairs. I start filling from terminal atoms, not from the central atom. So from oxygens here, not from phosphorus. Let's check. I have 16 pairs. This is my first pair. Second. 3. 4. 5. 6. 7. 8. 9. 10. 11. 12. I've put 12 pairs on the terminal atoms. Now what about the central atom, which is phosphorus? It still needs 8, and these oxygens still need 8. They have 6 now, so let's connect them with bonds. So we had 12 pairs, and here we have 4. This is 1, 2, 3, 4. 4 bonds, so 4 pairs. 12 plus 4, it gives me 16 pairs. So, this is your Lewis dot structure of PO4 3-. Don't forget, because it has a 3-, I will put it between these brackets and indicate the charge on top, which is 3-. So this is your Lewis structure. If you want to count the electrons, you will notice that each oxygen has 8 valence electrons, and the central phosphorus also has 8 valence electrons. Now sometimes you end up with having a central atom with more than 8 valence electrons. Atoms such as sulfur mainly, or selenium, sometimes other atoms also. You end up with having xenon also. You end up having more than 8 valence electrons in the center, and this will be tackled later on. So I hope you understood how to draw Lewis structures, especially the ones that are charged, so the polyatomic anions, and you need to practice how to draw these structures.